Welcome back, everybody. Today we're going to take a look at our quiz review for Chapter 3, go over these answers in detail. Let's start with that vocabulary. So for the vocabulary, the key word here is the Y value. Y values in output means that this first one would be range. X values in input show us domain. For number 2, a function whose graph is a non-vertical line is a linear function. A relation that pairs each input with exactly one output. So that exactly one output means that the relation is a function. A set of input values that consist of only certain numbers. So only certain numbers means that this is going to be a discrete domain. The set of input values that consist of all numbers means continuous domain. Let's see if I can make this a little easier to see. Continuous domain. Another name for y, denoted as f of x, is function notation. And the last one, number 8, if something does not have a constant rate of change, and the graph is not a straight line and non-vertical, then this is a non-linear function. So that's a review of that vocabulary. Determine if the relation is a function. Explain why. So remember, if something is a function, we're looking at the x values and saying, do the x values repeat? Now, in an ordered pair, the x values are the first value in the ordered pair. We have -3, -2, -1, 0, and 1. Yes, this is a function because none of the x values are repeated. If I look at number 10, I have 1, 2, 3, 1, 4. Well, those two ones in the x spots are repeated. So this is not a function because those x values are repeated. For our table in number 11, remember we're focused on the input, the x values. And so we check 0, 2, 4, 6, 8, 10. Nothing there is repeated, so yes, this is a function. For number 12, remember we're only worried about the input, the x values. And as you can see here for number 2, there's 2 lines coming off of number 2. That means 2 is repeated, so this is not a function. For number 13, if I use the vertical line test, you can see that every vertical line that I'm able to draw makes only touches our graphed dots one time. So yes, this is a function. No x value is repeated. There's no 2 dots. It passes the vertical line test, whatever of those that you would want to say. And on a side note, this would be a discrete domain. because we have just single dots. There's no line. So that means we can only have specific numbers. And again, I know it didn't ask that, but still, just to review. Number 14. Well, I pick a few different spots here for that vertical line test, and it touches the line that's graphed more than one time. So no, this is not a function. And as a side note for this, because we have a graphed line, this is a continuous domain. The dots are all connected. They're not just single dots. All right, for number 15 through 17, it's asking us to replace b with the value of 3 and find what the function is equal to. So b of 3, if this x changes to 3, that x has to change to 3 as well. So negative 3 plus 4 times 3. Following your order of operations, you do the 4 times 3 first, which is 12. And negative 3 plus 12 is 9. So b of 3 is equal to 9. I plugged 3 in for b, and I got an answer of 9. That's what that's saying. For 16, still changing b to 3. So 2 times 3 plus 7. This x changed to 3, and so did this one. Do parentheses first. 3 plus 7 is 10. And then 2 times 10 is 20. So when I replaced x with 3, I got an answer of 20. For number 17, we're still replacing 3 in. So 4 times 3 over 6 minus 5. Remember, we have to do whatever's up here first before we can do the division. So 4 times 3 is 12. 12 divided by 6 is 2. And then 2 minus 5 is negative 3. So b of 3 is equal to negative 3. We replaced x with 3. We got an answer of negative 3. (18) and 19 are now saying, I'm giving you the answer. Can you find x? That's the key here. Find x. G of x is negative 4. So I'm replacing g of x with negative 4. From there, solving for x. Remember, we're doing SADMAP for solving. We're going to add 2 to both sides. Negative 4 plus 2 is negative 2. And negative 2 plus 2 is 0. You can say this is 2/3 and multiply by the reciprocal of 3/2, or you can say this is 2 divided by 3. The last thing I said was divided by 3. The opposite of dividing by 3 is multiplying by 3 on both sides. Over on the left, 3 times negative 2 is negative 6. On the right, these 3's cross-reduce to 1, so you're left with 2x. My last step is to divide by 2 on both sides, and we get x is equal to negative 3. So when x is negative 3, the answer would be negative 4. Let's try 19. Now we're changing r of x to 21. So r of x is 21. Solve for x. The first thing we need to move is this 3. This is a positive 3, so the opposite of a positive 3 is a minus 3 or negative 3. 21 minus 3 is 18. 3 minus 3 is 0. Please, please, please don't forget that negative 6 in front of the x. Or sorry, that negative in front of the 6x. All right, and then this is negative 6 times x. So the opposite of multiplying is dividing by negative 6. 18 divided by 6 is negative 3. Negative 6 over negative 6 simplifies to positive 1. And so we have x is equal to negative 3. For number 20, we're talking about video games that you are renting, and you have $30 to start with. The independent variable in this case is R for renting. The dependent variable is M, the dollars left. Is the domain discrete or continuous? Well, I'm going to say it's discrete because if it's talking about renting games, you either rent the game or you don't rent the game. So we cannot rent part of a video game. All right, domain and range, discrete or continuous domain. For 21, we see dots. Because we see dots and they're not connected, this is discrete. The domain then is just going to be the list of values. So this is negative 3, negative 1, 1, and 3. Range are the y values. So we have negative 3, negative 1, 1, and 3 for the y. (22) Oh, look at that. These dots are all connected all the way through. So this would be continuous. Our domain starts at negative 1 and goes to positive 3. Our range, remember lowest to highest, our lowest y value is negative 3. And our highest y value is positive 2. Okay, this ends at 1, but this ends at 2. So that's my highest value. For 23, again, these dots are connected. So that makes this a continuous domain. Our domain starts over on the left at negative 3. And on the right, it stops at positive 3. Range, lowest to highest. Our lowest y value is here at negative 1. And our highest y value, yes, there's a 2, but there's this one over here that's even higher, and that's at y is equal to 3. All right, linear or nonlinear, and why? Well, if I look at these dots, here I am, I have to come back down to grab this other one. So this is going to be nonlinear. Your explanation can be it is not a straight line. Or because this dot over here, the change from our dot at 3, 1 to 4, 3 has a different rate of change. So rate of change is not constant. Either one of those would work. For 25, I'm not quite sure because I don't have a graph, but I can look at, well, -5 to 0 is adding 5. 0 to 5 is adding 5. So those are the same. Over here for y, 7 to 3 is adding 4, and 7 to 10 is adding 3. Well, that means this would be nonlinear. And from here, I have to say the rate of change is not constant. Okay, the rate of change is not constant. For 26, if I distribute to get rid of those parentheses, x times 2 is 2x. X times x is x squared. Well, this x squared tells me this is not going to be linear. This cannot be written in y equals mx plus b form because you have an x squared. And for 27, linear and nonlinear, well, this clearly is a straight line, so that makes it linear. But also, if I look at the rate of change, so if I go from here to here, this is up to right 3. I go from that spot to here, this is up to right 3. So the rate of change is the same. And it's clearly a straight line. All right, for graphing, remember you can use any 4 points you want to. In this case, let's see. I'll pick -2, 0, 2, and 4. You can use any 4 points you want to, but you should use at least one negative, one positive, and 0. So if I plug each of these into the equation for x, that's -2 minus 2 is -4. 0 minus 2 is -2. 2 minus 2 is 0. And 4 minus 2 is 2. If I plot these on my graph, -2, -4, 0, -2, 2, 0, and 4, 2. And then use your ruler or the edge of your notebook to draw your straight line there. For number 29, this time I think I'm going to use -2, -1, 0, and 1. So if I plug those in for x, we have -3 times -2 minus 1. -3 times -2 is +6, and 6 minus 1 is 5. -3 times -1 minus 1. -3 times -1 is +3. 3 minus 1 is 2. -3 times 0 minus 1. Well, -3 times 0 is 0. 0 minus 1 is -1. And -3 times 1 minus 1, -3 times 1 is -3. -3 minus 1 more is -4. Plotting that on my graph, I have -2, 5, -1, 2, 0, -1, and 1, -4. Oops, sorry about my line not being terribly straight there. I don't have a straight edge to put on my computer. But in a nutshell, that is our graph for 29. All right, number 30. When we have these AND problems, remember we separate this into two separate walls. With my x is a -11. So the opposite of subtracting 11 is adding 11. And remember, we have to add 11 on all sides of our wall. -2 plus 11 is 9. Our inequality doesn't change. We have x. -11 plus 11 is 0. And then 6 plus 11 is 17. So we have x is between 9 and 17. Graphing that solution, we have a closed circle at 9 and an open circle at 17. Closed because of the equal to here at 9, and open because it's not equal to at 17. And then because my x is squished in between those two inequalities, my shading is in between on my graph. (31) Putting it into slope-intercept form means you're getting it into y equals mx plus b, which basically means you're trying to get y by itself. So to get y by itself, we're starting with subtracting 4x. We're subtracting because this is a positive 4x. Now remember, we can't take 4x away from 10 because they are not like terms. So we're just going to have them sit next to each other on our paper. This is 2 times y. The opposite of multiplying by 2 is dividing by 2. 2 divided by 2 is 1y. 10 divided by 2 is 5. And -4 divided by 2 is -2x. So now we have put that in slope-intercept form, also known as getting y by itself. Number 32. Here we have an OR problem. So that means that these two problems cannot see each other until we're finished with solving on each side of the wall. So to get d alone over here, the opposite of adding 7 is subtracting 7. We have 2d. 7 minus 7 is 0. Now we're subtracting, not multiplying or dividing by a negative, so our inequality stays the same direction. -9 minus 7 more is -16. Divide by 2, and d, again, we're not changing the inequality sign because we're dividing by a positive 2. So d is less than -8. Over on the right side, 4d minus 1. So the opposite of subtracting 1 is adding 1. That's 4d. These add to 0 is greater than -2. The opposite of multiplying d by 4 is dividing d by 4. So d is greater than. We don't change the inequality sign because the 4 that we're dividing by is positive. And -2/4 I cannot divide evenly, but we can reduce that to -1/2. So if I'm putting this on a number line, (0, -2, -4, -6, -8. We would have an open circle at -8 because this is not equal to, and less than is going left. Then we have an open circle at -1/2. So we're estimating that right here in between the -1 and the 0. This is greater than is right. And so there's our arrow to the right. Remember, or means opposite arrows. Or opposite, or opposite. And last but not least, we have 33, solve for x. So now, instead of getting y alone, we want to get x alone. We have 3 times x minus 6. Our first step is going to be add 6 to the other side. Now 5y plus 6, I cannot add those together because 5y and 6 are not like terms. So instead, we are just going to make them sit next to each other on our paper. -6 plus 6 is equal to 0. The last step, this is 3 times x, so the opposite is dividing by 3. I can't divide 5 by 3 evenly, and I cannot reduce it, so I'm going to leave that as 5/3 y. 6 divided by 3 is 2, so plus 2 is equal to x. And that's it. X is now alone. I hope this was helpful as you're going through your review. If you have any questions, make sure that you reach out. Thank you so much for joining today. Have a great night.